All right, I'm continuing on with the weak, strong titration calculations that y'all started.
I found this on the web.
I don't want that. All right. That y'all got when Mr. Anderson is here. All right, we were at 0.3, I think. No, actually, yeah, we were at 0.3, half equivalence point is where we stopped, sorry. And that is your pKa is equal to your pH. So we did that one. I said that one should always be your easiest one. All right, point number 4. After the half equivalence point, so now we have added 30 milliliters of sodium hydroxide. So if I do 30 times 0.1, now I've added 3 millimoles of my hydroxide. So once again, if we, at this point, our acid, our hydronium ion, and our hydroxide ions are not equal. So I'm just going to kind of think of it as a skeleton neutralization reaction. I have 5 millimoles of my H+, that's what I started with, I hadn't changed. I added 3 millimoles of my hydroxide, so I need to subtract that. So that means at this point I have 2 millimoles of my acid and 3 millimoles of my base left. All right. So we're going to use that same formula. Hydrogen ion concentration is equal to Ka, etc. So my H+ concentration is going to be equal to my Ka, which was 7.2. 7.2 times 10 to the -4. And then my acid concentration would be my 2 millimoles I have left divided by my total volume. So that was 30 of my base and 50, so that is 80 mLs. And then for my base, I have 3 millimoles left, and it's that same volume. That 80 comes from the 50 originally of your acid, and then now at this point we've added 30 millimoles of, 30 milliliters of our sodium hydroxide. So when I do and I solve, I end up getting that my H+ is going to be equal to 4.8 times 10 to the -4. So negative log of that is going to give me my pH, which is going to be equal to 3.32. Hold on 1 minute. Let me make sure I got my right number going here. All right. Then we go to at our equivalence point. So at our equivalence point, our H+ should be equal to our hydroxide, which is going to be equal to our salt, which in this case, our salt's going to be our F-. All right, I'm going to get rid of some of this over here. Give myself a little bit more room to work. All right. So at this point, if we had, sorry, let me backtrack. Rewrite that. That's not concentration. That should be moles of your H plus is equal to moles of your hydroxide, which is equal to moles of your salt. And we're doing millimoles just so we won't have to change our milliliters every time. All right, so we've added 50 mils of our sodium hydroxide. So that would be 5 millimoles. That's why we're at the equivalence point. So we have five millimoles of my acid, 5 millimoles of my base, and that would be the same as the moles of my salt. So at this point, I have 5 millimoles of my salt. And we're using our hydrolysis reaction. Strong base, weak acid. And if you notice this here, the fluoride is acting as a base. It is a conjugate base of HF because it's accepting a hydrogen. So I don't need a Ka, I need a Kb for this. We were given the Ka, so I'm going to do my Kb. It's going to be 1 times 10 to the negative 14th, which is the Kw of water, and divide that by my Ka, which was my given Ka. And that gives me a Kb of 1.4 times 10 to the negative 11. That's going to be my Kb. And based off of this reaction, my Kb is going to be equal to hydroxide concentration times HF concentration divided by my salt, my F minus concentration. So now I can fill all of those in. And I end up with 1.4 times 10 to the negative 11th is equal to x squared divided by my fluoride concentration would be, I'm going to write it down and then I'll tell you where I got that from, would be 0.05, and then we would subtract x, but we're going to neglect x. So where I got this 0.05 from, we said we had 5 millimoles of salt, which would be my F minus. My salt is my F minus. Remember, because the cation portion of it would be in solution, it's a spectator ion. 5 millimoles, and then we needed to divide that by everything that we've added. So we had 50 milliliters of the acid and 50 milliliters of the base. So divided by 100 milliliters is where I get my 0.05, where I get that concentration. All right, so I'm going to kind of just finish up from here. So when I solve for x, I get x is about equal to 8.4 times 10 to the negative 7 molar. And I need to realize that this is my hydroxide concentration. So when I take the negative log of this, that's going to give me my POH, which is equal to 6.08. And then to get my pH, because that's what the question is, I'm going to take 14 minus 6.08, which is going to be equal to 7.9. Which what we said we would have a basic salt at the equivalence point. Not very basic, but it is basic. All right, so that's the equivalence point, and then we're going to look at a spot past the equivalence point. So once again, now we're going to have excess hydroxide because we've gone past the equivalence point. So we're going to have H plus OH minus. We can just go back to looking at this basic skeleton reaction. 5 millimoles of my acid, that never changed. 60 times 0.1. At this point, that means I have 6 millimoles of my base. It used up all of the millimoles of acid. So I have 1 millimole of my base left. All the acid's been used up. It's ended up being the limiting reactant at this point. And this is what I have left, 1 millimole of my hydroxide. And my total volume is 110 mLs, 50 originally and 60 here. So I get a 0.0091 molar hydroxide concentration. That's a strong base. So I need to take the negative log of 0.0091. And that's going to give me a pOH equals 2.04. The question is, what is the pH? So 14 minus 2.04 is going to give me 11.96. So that is my pH when I'm over really just by 1 millimole. So you can see at this point, I've moved past the buffering part of this system. And that's why all of a sudden you're seeing such a drastic change in the pH. Before that, when we were in the buffering part of it, we were just seeing small changes at pH. But now here, we're past that. So now all of a sudden, we're going to see a large drop in that. All righty, I'm going to stop here on number 1 and I'll record number 2 after school.